Question 1a, how many factors are there in 36? So we will just list it down. So 1 times 36, and there are 2 times 18, 3 times 12, 4 times 9. Okay, and then 5, can we do that? Nope. Then 6 times 6, then can we do 7? Nope. 8, nope. And then 9, then we continue off from there. So we'll just count 1, 2. So this will be 2 factors. 2 factors, 2 factors, 2 factors, and 6 is 1 factor. So total factors is equal to 2 plus 2 plus 2 plus 2 plus 1 equal to 9. So that means there are 9 factors for 36. Question 1b, write down the first common multiple of 4 and 10. So we will write down multiples 4, which is 4, 8, 12, 16, and 20. Then for multiples of 10, it is 10, 20, dot, dot, dot. So the answer should be 20. Okay, there you go. So that's the answer, 20. Let's move on. Question number 2. The table shows the time taken by 4 swimmers to complete a race. The time taken by Bala to complete the race is not shown. The average time taken by 4 swimmers was 48.7 seconds. What was the time taken by Bala? So basically, to find Bala, we just need to have total and then minus all of the numbers. So to get the total, we will then get number of swimmers times the average. So the number of swimmers is 4 times 48.7, and this will give us 194.8. Then to get Bala, we just have total minus the rest of swimmers, which is 194.8 minus 50.78 minus 48.12 minus 46.9. And this will give us 49 seconds. All right, there you go. Question 3. The figure is made up of a square and 3/4 circle. The 3/4 circle with center O has a diameter of 8 centimeters. What is the area of the figure? Take pi as 3.14. So the area of figure is basically 3/4 circle area plus square area. So the 3/4 circle area diameter is equal to 8. So the radius will just be half of it, which is 8 divided by 2. And this will give us 4. So to get the area, basically 3/4 times pi times radius, and this will be 3/4 times 3.14 times radius is 4 times 4, and this will give us 37.68. Then we will get the square area, which in this case is 4. So that means it is 4 times 4, which is 16. So area of figure is basically 3/4 of circle area, 37.68, plus the square area, and this will give us 53.68 centimeter square. Okay, there you go. So that's the answer, 53.68. Question 4a. Jack wanted to create a figure using white squares and gray squares with PQ as the line of symmetry. He still had more squares to add. Measure and write down the length of PQ. So I have a ruler. Then I just mark out the two ends of the line. So it starts from 0. And then if you look closely, it's 6.4. So therefore, the answer is 6.4 centimeters. So part B is, what are the smallest numbers of white squares and gray squares Jack needs to add to the figure so that PQ remains as the line of symmetry. So if you want to make this a line symmetry, it needs to be mirrored. So first, we have 1 over here. We got 1. Okay, so we always want to look here. So 1 and 1, 1 and 1, 1 and 1. Okay, this one is also good. What about this one? Okay, we need to add another gray square over here. Then this is okay. What about this? We need to move it over here. So that means this is the white square. And then we have this one as well. So then move it over. Right? So there's one more over here. Okay. So let me color this a bit more so you can see. Okay. So we have the 3 whites and 2 blues. So in total, we will have 5. So white, squares, red. equal to 3. And then gray squares is 2. So total 3 plus 2 equal to 5. Okay, there you go. Question 5. ABC and FEH are triangles and CFGD is a trapezium. BC, EFG, and ACFH are straight lines. Find the sum of x, y, and z. Okay, let's start with the simplest one, which is angle y over here. So angle y is basically 180 minus 81, and this will give us 99 degrees. Reason is adjacent angles in trapezium adds to 180. So now we are left with x and z. So the thing is that we know for angle DCF is equal to angle ACB. So they are in blue. Okay. And angle CFG is equal to angle EFH, which is in red. Okay. So if you were to write down the equation for triangle ABC and FEH, so in essence, 180 is equal to 23 plus angle X plus ACB, which is in blue. Then the next one is 180 is equal to 88 plus angle Z plus angle EFH, which is in red. And we know that DCF, which is in blue, which is in the trapezium, plus CFG, which is in red in the trapezium, is also 180. So if you were to add these two over here, or basically which means 180 is equal to the same thing, ACF in the red triangle plus ACB, which is in the blue. If we were to add these two equations, right, ABC plus FEG, that means it's 180 plus 180 equal to 23 plus angle X plus ACB, which is in blue, plus EFH plus 88 plus Z over here. And the thing is, earlier we saw that ACB plus EFH is 180. Then we can swap it out and this will be our equation. So 180 plus 180 is equal to 23 plus X plus 180, because ACB plus EF that we went through is 180 plus 88 plus Z. And if we were to simplify everything, so this will be equal to 360 equal to 291 plus X plus Z. So we can find X plus Z, which is basically equal to 360 minus 291. And this will give us 69. Then we found out angle Y, right, which is 99. So angle X plus angle Z plus angle Y is equal to 69 plus 99. And this will be equal to 168 degrees. There you go. So the answer is 168. Question 6a. The table shows the number of boys and girls and teachers in schools A and B. Some of the information is missing. What is the total number of boys in both schools? So pretty straightforward. We know the total is 4642. And then teachers is equal to 251. And then girls equal to 2460. So boys would then be equal to total minus teachers minus girls in essence will be equal to 4642 minus 251 minus 2460. Okay, and this will be equal to 1931. Okay, there you go. So that's the answer. So part B, part B, the number of girls is 2/3 of the number of girls in school B. Find the total number of students in school A. So since this statement over here means school A is equal to 2 units, school A girls is 2 units, school B girls will be 3 units. So total girls units will then be 2 plus 3, and this will give us 5 units. So that means 5 units is 2460. Then for school A will then be equal to 2 units. So 2 units will then be equal to 984, which is the school A girls over here. Then we can get the teachers in school A is equal to 251 minus 154, and this will give us 97. So the total, actually no need the teachers, of course we want students, right? So the total students in school A is equal to 845 minus a plus 984, and this will give us 1829 or 1829. Okay, there you go. Question 7. For every mobile phone that Susan sells, she earns a sum of money as shown. 10% of the first $160 of the selling price and 12% of the remaining selling price. Susan sold the mobile phone and earned $76.90. What was the selling price of the mobile phone? So from the first statement, 10% of the first 660, she earns 10% of first 160, so which is 10% times 160, which is equal to $16. So that means the remaining will then be equal to 76.90 minus 16, and this will give us $60.90. Since this says here 12% of the remaining selling price, that means 12% is equal to $60.90. So 100% would then be equal to 60.90 divided by 12 times 100, and this will give her $507.50. So the selling price is basically 160 plus remaining price. And we know the remaining price, which is 507.50, and this will give us $667.50. All right, there you go. Question 9. At a shop, erasers were sold in packets of 3 and pens were sold in packets of 9. Bella paid with a $50 note for 9 erasers and 20 pens. The cost per packet for erasers is Q dollars and for pens is 2Q dollars. How much change did Bella receive? So erasers will be $Q and then pens will be $2Q. So we know that each sold was 3 erasers and then 5 pens. Okay, from the question. So now we want to find 9 erasers, which will be 3 times Q, which is equal to $3Q. Then she bought 20 pens. So from 5 pens to 20 pens will be 2 times 4 will be equal to 8Q dollars. So the total would then be 3Q plus 8Q, which is equal to $11Q. So she paid with a $50 note. So the change would then be equal to 50 or dollars. 50 minus 11Q. This will be dollars bracket 50 minus 11Q. That's what you see over here. So that's the answer. So question 10a. Julie's coin box contained 20 cents and 50 cent coins. In the coin box, there were 7 more 50 cent coins than 20 cent coins. The total amount of money in the coin box was $18.90. How many coins were in the coin box? So the number of coins will look something like this. So we want to find out the total without 7 50-cent coins. Is basically 18.90 minus 7 times 0.5. This will give us $15.40. This means, or this $15.40 means there is an equal number of 50 cents and 20 cent coins. So let's put like one group, would then be 150 or 150-cent coins and 120-cent coin. So one group value will be 0.5 plus 0.2. This will give us 0.7. So number of groups will then be equal to total without the 750-cent coins divided by one group value, which will then be equal to 15.4 divided by 0.7. This will give us 22. So we want to find the number of coins in the coin box. So one group total coins is equal to 2 coins, right? Which is 150-cent coin plus 120-cent coin is 2 coins. So 22 groups then be equal to 2 times 22 equal to 44. Total would then be 44 plus 7, and this will give us 51. Okay, so the answer is total 51 coins. So question 10b, 10 part B, how much money does Julia have left in the coin box after spending all her 20-cent coins? So we know got 22 groups, so total 20-cent coins value is basically equal to 44 times 0.2, and this will give us, actually no need. You can just find if she spent all the coins or 20-cent coins, that means she is just left with the 50-cent coins. So that means total 50-cent coins then be equal to 22 plus 7, which is equal to 29. So total 50-cent coins value slash Julie left, which is basically 29 times 0.5, and this will give us $14.50. There you go. So that's the answer. Question 11. Adam cut a rope into 3 pieces. The first piece was 4.5 meters longer than 1/4 of the original length of the rope. The second piece was 3.3 meters longer than 3/5 of the remaining rope after the first cut. The third piece was 8.7 meters. What was the original length of the rope? So in this case, what we want to do is we want to create a model. So we're just going to draw a simple rectangle to signify that this is the original length of the rope. So first thing is the first piece was 4.5 meters longer than 1/4 of the original length of the rope. So we will just want to cut 1/4. So just cut like this, 1/4. And the first piece was 4.5 meters longer. So that means it will look something like this. The first piece is 1/4 of the original length plus 4.5 meters. Okay, so now let's move on to the second piece. The second piece was 3.3 meters longer than 3/5 of the remaining rope at first. So the remaining rope is like this. So the remaining rope looks something like this. Then it says here the second piece was 3.3 meters longer than the 3/5 of the remaining rope, which will look something like this. So 3/5 of the remaining rope plus 3.3 meters. And the last one is the third piece, which is this one over here. So the third piece is 8.7 meters. So what's the original length? Okay, so from here, what we can do is we can find out 2/5 of remaining rope, which is basically, so if I were to extend this out a bit, will look something like this, right? 2/5 is basically 3.3 plus 8.7. And this will give us 12 meters. So we want to find 5 out of 5 remaining rope. So we can do 1 out of 5 remaining rope as well. So 1 out of 5 remaining rope is basically 12 divided by 2. This will give us 6 meters. Then 5 out of 5 is 6 times 5. And this will give us 30 meters. So now we know that the remaining rope is 30 meters. Then can we get the original length of the rope with what we see over here? Yes, we can. So you can see that the remaining rope over here plus 4.5 is actually 3/4. So that means 3/4 of original rope will then be equal to 30 plus 4.5. And this will be 34.5 meters. Then 1/4 of original. So yeah, 1/4 of original rope is 34.5 divided by 3 is 11.5. So the total length of the original rope, 4 of the original rope is 11.5 times 4. And this will give us 46 meters. Okay, there you go. So that's the answer, 46 meters. Question 12, part A. Mrs. Brown bought 2/5 as many cupcakes as pies for a party. She spent 3/4 as much on each cupcake as each pie. Each cupcake cost $4.50. She paid $504 more on the pies than the cupcakes. How much did she pay for each pie? So from the question, we know that she spent 3/4 as much on each cupcake as on each pie. So what that this mean? So this means that one cupcake cost is 3 units and one pie cost is 4 units. And we know here that from the question, it says here, each cupcake costs $4.50, which means that the cupcake costs 3 units is $4.50. That means 1 unit will be $1.50. So can we calculate the price of each pie? Yes, which is 4 units, which is 1 pie cost. That means it is 4 times $1.50, and this will give us $6. Okay, there you go. For part B, she paid $504 more on the pies than the cupcakes. How many pies did she buy? So from the question, it says here that Mrs. Brown bought 2/5 as many cupcakes as pies for a party. So we're going to use this concept called the grouping concept. So which means from the question, one group is equal to how many? 5 pies and 2 cupcakes. So 2/5 as many cupcakes. So 2 is cupcakes, 5 is pies. So one group will be 5 pies plus 2 cupcakes. But the thing is, from the question, she says here she paid $504 more than on the pies than the cupcakes. That means the total difference between the total pies and total cupcakes spent is $504. That means we can find one group difference from 5 pies and 2 cupcakes, which is equal to $21. Since we know one group difference is $21, then we can get the number of groups by dividing the total difference divided by one group difference, and this will give us 504 divided by 21 is 24. Now the question asks, how many pies did she buy altogether? So we know that from one group earlier, it is equal to 5 pies. That means the total pies is equal to 24 groups times 5, and this will give us 120 pies. So that's the answer, 120. Question 13a. There were some apples and orange in a box. In the morning, when 24 apples were added to the box, the ratio of the number of apples to the number of oranges in the box was 60:5. Then 35 oranges were removed from the box and the ratio became 4:1. How many apples were there in the box at first? So in this case, if you see a before, right? Okay, so this one is a bit tricky, but you just need to know if there is a ratio, something happened, and a ratio after, then we can make use of this thing called the before change and after table. So you can write here apples and orange. So at first it's 6:5, and then 35 oranges were removed, so minus 35. And then after what happens, the ratio becomes 4:1. Since the apples remained the same, this is what we call the constant part concept. So that means you want to make the apple the same number because they literally didn't change at all. So we want to use the lowest common multiple, which is 6 and 4, and this will give us 12. So then we will multiply the apples and oranges accordingly, and this will look something like this. So apples and oranges, they will just become 12. So 6 times 2, 4 times 3. Since they are the same, then we also do the same with oranges, 5 times 2 and 1 times 3. So you see that the oranges before is now 10 and after is 3. So from here, we actually can create the equation. The difference or the change in here will be 7 units will be 35. Then that means we can calculate for 1 unit, which is equal to 35 divided by 7 is 5. Now the question asks, how many apples were there in the box at first, right? But the thing is that in the morning, okay, but before, we want to get 12 units first lah. Because we want to find the apples before, which is 60 over here. So we want to find the number of apples, but from the question it says here, in the morning when the 24 apples were added, the ratio becomes 6:5, right? So that means we need to minus off 24 from 60. And the final answer to this is apples at first will then be equal to 60 minus 24, and this will give us 36, which is the answer over here. So for part B, in the afternoon, more apples and oranges were added into the box. The number of apples increased by 65% and the number of oranges increased by 120%. Find the total number of apples and orange added in the afternoon. So number of apples increased by 65% means 65% of the apples are added. So apples added is basically 60 times 65%, and this will give us 39. And the next part is number of oranges increased by 120%. That means 120% of oranges are added. So oranges added is equal to, we need to know how many oranges, right? At the end, which is 3 units. So 3 units equal to 3 times 5, which is 15 oranges. So that means it's 15 times 120%, and this will give us 18. Therefore, total apples and oranges added would then be equal to, in this case, 39 plus 18, which is equal to 57. Okay, there you go. That's the answer, 57. Question 14. The figure shows tab A and B, a rectangular tank X, and cubical tank Y. Very important hint. Both tanks were empty. At 8:20, tab A was turned on. Water flowed into the tank from tab A at a rate of 4.8 liters per minute. After 5 minutes, tab B was turned on. At 0835, both taps were turned off. Tank X was filled with water, and tank Y was 25% filled with water. Find the length of tank Y. So we know from this, 8:20, tab A was turned on. The next thing is, at 8:35, both taps were turned off. And lastly, tab A at a rate of 4.8 liters per minute. So that means we can actually find the total water in both tanks. So first we need to find the duration of tab A being turned on, which is basically 8:35 minus 8:20, which is 15 minutes. Then we can find the total water in both tanks, which is basically 4.8 liters per minute, right? So that means we have 4.8 times 15, and this will give us 72 liters. So we know that tank X was filled with water. So from the diagram, we can see the dimensions of tank X. So that means tank X half filled will be, or basically, this 72 liters, right, over here is equal to this part, right? I'm just going to put this statement over here. So the total water will be tank X half filled and tank Y 25% filled, which means half of tank X plus 25% of tank Y. So this is what we need to know. Then we can find out tank Y from here. Then we can solve because tank Y is a cubical tank. So first we need to find how much is tank X volume of water. So tank X half filled is basically half the volume, which is half times length 30, breadth 20, and height 60, and this will give us 18,000 centimeter cube, or equal to 18 liters. Then that means the water remaining is 72 minus 18, which is 54, which is also what is tank Y 25% filled. And the thing is, we can actually calculate what is tank Y 25% filled. So if tank Y 25% filled is 54, then tank Y 100% filled will be 54 times 4, and this will give us 216 liters. And from the question, a cubical tank Y, and we want to find the length of tank Y. So basically, for cube is length times length times length. That means length of cube is basically equal to cube root of cube volume. So once you know this, then we actually can find the length of the cube. We need to convert this 216 liters to centimeter cube. So 216 times 1000, 216,000 centimeter cube. As what you see over here. So length of cube is cube root of cube volume, which will then be equal to cube root of 216,000. In this case is 60 centimeters. So there you go. So that's the answer, 60 centimeters. Question 15a. A florist sold roses from Monday to Sunday. The line graph shows the number of roses left unsold at the end of each day. On which day had the florist sold half the total number of roses for the week? First thing is we want to look at the gaps. And we want to find out how many gaps is the number of roses. How many roses is one gap? Okay, so over here we have 1 gap, 2 gap, 3, 4, and 5. So right here 5 gaps is equal to 200. Then 1 gap is equal to 200 divided by 5. This will give us 40. Okay, so in this case over here, what is the total amount of flowers we have in 1 week? So 1 week flower is equal to 1200. Then half of 1 week flower is basically 1200 divided by 2. And this will become 600. What I see over here. So we want to find out which day is 600. So we can just look at 600, draw a line to the 600, and you see there is a point. And can you guess which day it is? If we were to go down, it is Wednesday. So therefore the answer is Wednesday. So part B, on which 2 days did the florist sell the same number of roses? So we need to find each day and see which day has the same number of roses sold. Okay, since we know 1 gap is 40, so we just measure for each day. So for day Monday, we are left with not 1000 but 950. So Monday left is 960. Sorry, 960. So that means Monday sold is basically 1200 minus 960, and this will give us 240. Okay, let's move on to the next one. Let's go to Tuesday. So Tuesday over here is in the middle, as what I see over here. So that means it is 2 gaps. So we are going to do the same thing. Tuesday left, it's basically 840. So for Tuesday sold, we just minus 960 minus 840. And this will give us 80. Sorry, is it 80? So it's not 840, 880, because 2 gaps. Mabayad. Okay, so this will give us 80. Okay, so I did the same? Nope. Let's move on to the next one. The next one is Wednesday. Wednesday is 600. So Wednesday, we are left with 600. So we are sold 880, which is Tuesday. And then minus 600, this will give us 280. So is it the same with anything? Nope. Let's move on. Okay, Thursday over here. And Thursday is somewhere here. So if you look at Thursday, it's 480. So Thursday we're left with 480. Thursday sold is 600, which is the day before, minus 480, which gives us 120. Is it the same with any of the days? No. Let's still continue to the next day. So for Friday, if you look at this, it's only 1 gap above 400, which means it is 440 for Friday. That means we are sold not a lot actually, which in this case is 40. Let's look on Saturday. So Saturday, I'm going to put it blue. And Saturday, if we were to just go all the way here, it is 200 and so 3 gaps. So 320. So Saturday left is 320. So Saturday sold is 440 minus 320, and this will give us 120. Is 120 the same as any other day? Yes, Thursday. So that means Saturday and Thursday are the same. Okay, there you go. So for part C, it says here the usual price of a stock of rose was $9. On Saturday, after selling 52 stocks of roses, the remaining roses were sold at a discount of 25%. What was the total amount collected on a Saturday? So Saturday, we know that we are left with 320. And we know from the previous question that Saturday sold is 440 minus 320, which is Friday over here. So we sold the total number of 120. So remaining roses is basically 120 minus 52, and this will give us 68. So that means the total amount collected on a Saturday is basically 52 times 9 plus. So we want to find out what is the discounted price of 25%. So discounted price in percentage, we go to 100 minus 25. This will give us 75%. So discounted price in terms of dollars would then be 9 times 75%. And this will give us dollars 6.75. So the remaining 68, we multiply it by 6.75, and this will be equal to $927. So that's the answer, $927. Question 16a. A trapezium ABCD is drawn in a square grid using the line DW. Draw an isosceles triangle DWX that angle DWX is less than 90 and DW is equal to WX. So basically we need to create another line to create this, I would say, isosceles triangle. That's what you see over here. And we want to make sure that X over here, the angle DWX is less than 90. So if it's like this, which is definitely more than 90, then this is wrong. So first we need to measure the length of DW. How do we measure length? It's basically forming a triangle. So in this case, to form a triangle, just using DW, it's basically how it looks like this. So across, so you have to create a right angle triangle. So you have to count, right? You have 1, 2, 3, and 4. So that means this is 4 line across. That's what you see over here. So 4 line across. And then from here, when you point down to W, then this means it's 2 lines below. So with that said, you want the DW X to follow you can take it as the height and base of this measurement. So in this case, for example, if you were to take 4 across, something like this, and then 2, then you can get the same length of this line over here, something like this. Okay, so then how do we create an isosceles triangle? So what you need to do is, generally, you just have this, I would say, base, and the height form somewhat like a rectangle or square, something like this lah. Okay, so that means the line DWX will actually be over here. So then at the same time, this angle over here, if you were to look at the line just from seeing it, is definitely less than 90 degrees. If you want to really double confirm, you can use a ruler or right angle protractor just to see whether it is a less than 90 degrees. So if I were to put it over, you could see that it's less than 90 degrees. Then once you have connected to or drawn the line, then therefore you can just create the triangle as what you see over here. So there you go. So that is how you create this triangle. Question 16c. LMNO is a square and ONP is an isosceles triangle where ON is equal to OP. Given that angle LNP is equal to 103 degrees, find angle OPL. So first thing is we just want to mark out all of the equal sides. So since this LMNO is a square, the equal sides look something like this. And then we know that from the question, ON is equal to OP. That's what we see over here. So the thing is that since ON is equal to OP and ON is equal to LO, then that means from this triangle, because we are looking at this angle that we're looking for over here, that means this triangle that you see in red is actually a isosceles triangle. Why? Because since ON is equal to OP, which is over here, and ON is equal to LO, as what you see over here, that means OP is equal to LO, which means that the triangle LOP is an isosceles triangle. So that means angle OPL is 180 minus angle LOP, which is this purple angle over here. And then we divide by 2. So what is this angle LOP? Since we know that this whole thing is a square, so that means this angle LOP over here consists of two things. The first one is a right angle because this is a square, and the second one is this angle NOP. So angle LOP is basically LON, which is in blue, and NOP, which is in green. So we know that angle LON is 90 degrees because it's the corner of a square. So the next thing is we want to find is this green angle over here, which is NOP. So how do we do that? Since we know ON is equal to OP, that means the triangle NOP over here is an isosceles triangle. So this means that angle NOP is, which is the green angle, is equal to 180 minus angle ONP, which is in orange over here, times 2 because it's an isosceles triangle. So how do we get ONP? So ONP over here is 103 minus LNO. So ONP is orange, 103 is this pink angle that says 103 over here. And LNO or angle LNO over here is the blue angle. So what is this blue angle over here? So the thing is that since we know that the corner of this is a square, the corner of the square is a right angle, and the line from L to N is half of a square, that means this angle LNO is basically 90 divided by 2, which is 45 degrees. So that means angle ONP is 103 minus 45, and this will give us 58, as what you see over here. Since we know the blue angle, the next thing is we can find the 58 is the orange angle, my bad. So LNO is actually 45 instead. So now we know the orange angle, ONP. Then we can find our green angle over here, which is this. So this is NOP. So that means we have 180 minus 58 times 2. And this green angle over here will be 64 degrees. Since we know the angle NOP, we can find the purple angle, which is LOP, which is 90 degrees plus 64, which is 154. And since we know the angle LOP, then that means we can find the answer to the question OPL, which is basically 180 minus 154 divided by 2, and this will give us 13 degrees. And that is your answer. Question 17a. The first 4 figures of a pattern are shown below. The table shows the number of white and gray circles used for the first 4 figures. Fill in the table for figure 5. So you can see here that there is figure 1, which only has 1 gray. So what we're going to do different is we're going to add or show the total. So for figure 2, it is 1 gray plus 5 white, which is 6 total. For figure 3, it is 5 white plus 10 gray. And then for figure 4, it is 10 gray plus 18 white, which is 28 total. So what is figure 5? I'm going to make use of the total in order for us to figure out how many gray circles are there. So in this case, let's just make it a bit simpler to see. We got figure 1 with 1 total, figure 2 with 6 total, figure 3 with 15 total, and figure 4 with 28 total. So I have the figure numbers here. So what do you think we can do to make the total from the figure number? So let's say 1 times 1 is the first one. How about 2? To get 6, we multiply by 3. For 15, we multiply by 5. For 4, we multiply by 7 to get 28. So the thing is that, what is this 1, 3, 5, 7? So 1, 3, 5, 7 are odd numbers. So how do we find odd numbers according to the figure number? Okay, but in this case over here, since it's figure 5, we can just put figure 5 as 5. And then what's the odd number after 7? 9. which is 45 total. So since we know the number of white grays is 18 white, so figure 5, gray is 45 minus 18, and this will give us 27. So the answer over here is 27. So actually no need to do this. So you can just figure out for figure 5 and you got the answer. So for part B over here, how many white and gray circles are there all together? So since we are able to figure out figure 5, that the answer is figure times the odd number. So the equation for total will be figure number times figure odd number. So how do we find the figure odd number? So over here, we can see first odd number is 1, second odd number is 3, third odd number is 5, fourth is 7, and fifth is 9. So I usually put the figure number 1, 2, 3, 4, 5 to figure out how do we get the odd number according to the figure odd number. So in this case, how do we get 2 to 3? Right, we plus 1. It can't be plus 1 because if we have the first one 2, plus 1, it will get us 2. So what about something similar? If we multiply by 2, we will get 2 for this case. We will get 4, we get 6, we get 8, and we get 10. So we are very close. And the number that we calculated when we multiply by 2 is always 1 behind. So our numbers are just one number behind the even number. So that means we minus 1. And this is the equation to find the figure odd number. So the first odd number will be 1 times 2 minus 1. Second will be 2 times 2, which is 4, minus 1 is 3. 3 times 2 minus 1 is 5. 4 times 2 minus 1 is 7. 5 times 2 minus 1 is 9. So to find the 28th odd number is 28 times 2 minus 1. And this will give us 55. So the equation for the total is figure number times the figure odd number. So which means this will be equal to figure number 28 times 55, and this will give us 1540. So there you go. So the answer is 1540. Sorry, 1540.